All right, today is the first in the series, okay, a two-part series on concentration of solution. So today we're going to be talking about percent and parts per million concentration. And there's other ways of doing concentration, and we'll get to those another time. Part two. So concentration, logically, but also for all of these things, is the amount of solute in a standardized amount of solution. How I measure that amount, or how I state that amount, is going to change from one to the other, and the standard unit is going to change from one to the other as well. Not going to be three different ones, or a lot of different ones, but they're going to be a little bit different, and it's going to be your job to know which one to use when. And I think it's worthwhile to know that while you'll usually be told, or it'll be usually fairly obvious what kind of concentration you're going to need to express, it won't always be pop off the page, poke you in the eye obvious. And yeah, when we're talking about an amount of solution, it could be a mass, it could be a volume, it could be a number of moles. When I'm talking about the amount of solution, not solvent by the way, but solution, that's usually going to be a volume. For our purposes, we're only going to look at non-volume methods a little tiny bit. It's almost always going to be a volume. Okay, so as I said before, sometimes I'm going to specify which kind of units to use, but oftentimes it will just be assumed that when we say concentration and you're given certain data to use, you'll know what to do with that. Okay, now percent, parts per million, those are the ones we're talking about in this one, and then we'll talk about molar concentration, which will sometimes be here being called molarity by old people who've been in chemistry for a long time, but those are the three that we're going to be looking at. Okay? So we're going to start with percent. Percent, as you know, is always the part out of 100, or what would it be if I had that ratio in 100 of them? So part divided by the whole, just like you would do on a test, times 100 to get the percent. In terms of concentration, sorry, I take that back, we can also write the unit or express it a little bit differently if I rearrange that formula a little bit. For our purposes, there you go. For chemistry, it is the mass of the solute divided by the volume in milliliters, and then we're going to multiply that by 100. Now that might take a couple of different looks as well, but we'll kind of get into that as we go along. So for the most common one that we're going to use is what's called a WV, or weight volume concentration. It is the when you have a solid solute and you're finding the mass of that solute, and then you're dissolving that into a liquid solvent to make a liquid solution, kind of like salt going into water. In that case, the percent concentration specifically is the mass in grams of solute divided by the total volume in milliliters. That's going to be key. Multiply that by 100. Okay. And really what you need to be thinking is percent is the mass in 100 milliliters of solution. So if I take this one, for example, 32 grams in 850 milliliters of solution, and I want to know the percent concentration, I don't have to specify WV. It's sometimes helpful but not required. 32 grams divided by the total volume in milliliters, multiply that by 100 would give me 3.76%. Too easy. If I had 2.5 grams and 1.6 liters of solution, it's going to be almost exactly the same thing, same idea anyway, but now I have to remember to turn my total volume into milliliters, because percent is the mass in 100 milliliters. So I would convert the volume into milliliters, multiply by 1,000, then it's going to be mass divided by total volume in milliliters times 100 to get the percent of 0.156. Too easy. Now I can also have a volume, and you'll see these in a few different places. Vinegar is a great example where it will tell you, if you look at the label, it will tell you it's a 5% solution by volume. It doesn't really matter what the solute is, we'll get there to another time. But that would be the volume of liquid solute in a total amount of volume of liquid solution. It would be a similar kind of thing. All I have to keep an eye on there is units. But in that case, it wouldn't make sense to measure the mass because my solute is also a liquid. So then I do a volume. If I were to do that, it would look very similar. I'm not going to go through it in any level of detail because the math is identical. I could also have a weight. Now this is really common in alloys, for example, where it wouldn't make sense to measure the volume of the solute or the solution. So I end up with both solids. I will find the mass of each. But again, the math is going to be exactly the same. I may have to specify that it's a weight. Again, not all the time. there are certain times where it just does not make sense to try and measure volume, or likewise doesn't make sense to measure weight. So solving that one, if you have not done so already, then I end up with the mass of the solute divided by the mass of the solution. Both are going to be in grams, and then multiplied by 100. Carry on. Moving on to parts per million. Parts per million are going to be useful when I'm dealing with a solute that is in very, very, very small a concentration. So you'll find this with contaminants in water. If you were to look up Health Canada and see what the level of lead in your water is, it's probably not going to be a parts per million. It's probably going to be a parts per billion, but similar kind of thing. And air quality. There again, sometimes the air quality is going to be in parts per billion, which means an even smaller concentration, which is good if it's contaminants. That one specifically is the milligrams of the solute in 1 liter of solution. Keep an eye on the units. You know this is where I'm going to be trying to put things, or trying to trip you up a little bit, is playing with the units. It's got to be milligrams in liter. So another way I can write it is that way: the mass in milligrams divided by the volume in liters. Okay. Now, give an example. If you had 18 milligrams of solute in 850 mils, oh, you got you on the milliliters, then I'm going to convert that volume into liters and do mass divided by the total volume in liters, 21.2 parts per million. It's not that hard. Okay, which brings us to the end of the first of the series of 2. There you go. You should be able to work with percents. Our primary one, as I said before, is going to be a weight-volume type percent, but weight or volume, it's no different in terms of the math. And also parts per million. Now, parts per million are not some ones that we're going to use a lot. They kind of have a fairly narrow use, but you still need to be familiar with them. Talk to you another time.